So we now have beams circulating clockwise and anti-clockwise in the LHC to produce collisions, but the two beams need to be captured by the RF radio frequency system. Can you explain this capturing process to us and how long it took?
Well, there was two phases. We decided to go for a fast capture on I think it was the Friday evening, and basically we asked the RF people to go to point 4 where the system is installed, and they switched on the RF system to the same frequency as the beam, and it captured first time. It was unbelievable. But I think this was helped by the fact that two things. First of all, we had measured many turns of the beam going round. The beam was going round without capture for something like 500 turns. So what you need to do then is measure the frequency of the beam, try to measure the phase, and switch on the RF system. And as far as I understand, what was done is they set exactly the same frequency as they did 14 months ago, and it worked.
Oh gosh, that was pot luck, but very good indeed, and shows the quality again of the operations teams.
But since then, they have come back and done the job over an 8-hour shift, and now the capture is perfect.
Terrific. Can you talk us through the steps that are going to be performed to the collisions at 3.5 tera-electron volts per beam?
Well, the steps, first of all, we have some work to do early next year to prepare the machine for the higher energy. Then what we will do is, this is preparation. What we're doing now is preparation, of course, for injection. We will accelerate the beam before Christmas to something like 1.2 TeV. Next year, after we do the repairs, which will allow us to go to 3.5 TeV, then we will do the same things we've done now, inject at 450 GeV, prepare what we call the energy ramp to 3.5 TeV, and make sure that all of the parameters are constant during the ramp. That means for us, the Betatron tune, which probably doesn't mean too much to you, but it's one of the parameters which must remain constant during the ramp. And also we have to make sure that what we call the closed orbit, which is the trajectory inside the vacuum chamber, stays constant as we increase the energy. If we can do that, and we have systems for controlling that and making sure that they don't drift, then we should be able to get to 3.5 TeV. When we get to 3.5 TeV, then we'll have to bring the beams into collision. And bringing the beams into collision. Before we do that, we will also focus much more strongly the beams at the interaction points for the experiments, so as to increase the event rate which they see.
The physicists working on the LHC experiments are clearly eager to see the first collisions, already collisions at 450 GeV and then at 1.2 tera-electron volts before Christmas. These collisions will already be interesting to analyse, but what makes collisions at 3.5 TeV per beam so much more interesting from the physics point of view?
Well, of course it's the reason for building the LHC. It's the energy. We need... Well, the highest energy accelerator in the world at the moment is the Tevatron near Chicago, and it's working at 950 GeV per beam. So as soon as we get significantly above that energy, we can expect new physics.
The spokespersons announced first collisions in all experiments yesterday. Let's take a look at a few of the images.
It's really the beginning of a terrific era, and we are so excited today. And I think it's amazing that in weeks, months, and years to come, our excitement will have an additional escalation.
The machine put in the first beam. 2 minutes later, the second beam, and suddenly the experiment started ticking. So even before the computers realized that we had the first event, already the people in the counting room knew that something was happening. You see here the collision happened at this point, and you see all the tracks going out. All these are the signals from the detectors, whether everything works as it should, and it looks actually quite fine. So now the fun starts, now the young physics starts.
One million. 1 million? Yeah. 1 million trigger. Écoute, on a une amélioration de taux de comptage par rapport à on a des événements.
Honestly speaking, not. But you see, I'm smiling. I'm extremely happy that collision took place tonight. To me, it's a perfect proof that we have working detector, we have a beautiful collaboration which is necessary to make beauty physics. This is the main proof to me.
This is the first collision event that we've seen in CMS, so it's a very interesting moment as well. So you can see that the inner tracker of the CMS detector, the central part was off, the outer bits were on. In red is the electromagnetic calorimeter, so this is lead tungsten crystals, and the height of these towers tells you the amount of energy that has been deposited in these crystals. Blue is the hadron calorimeter, and these are different views of the same event. And here you can see the cylindrical nature of CMS, and you can see the energy being distributed all over the place. The two protons have collided in the heart of the experiment.
Judging from recent press coverage, the media is expecting great things from the LHC. Do you feel any pressure in this respect, and if so, how do you manage it?
Well, I don't feel much pressure, so I don't have to manage it. We'll do the very best we can, and I'm sure we will succeed, but I don't think it is as being pressure. It's part of our job.
What are the next major milestones for 2010 beyond collisions at 3.5 TeV per beam?
We will, sometime in the middle of the year, start making preparations for going beyond 3.5 TeV. Mm-hmm. We would like to go to 5 TeV during 2010. 5 TeV would be another major step. 3.5 is a very major step. But of course the design energy of the LHC is 7 TeV per beam. So we will try to, in 2010 to go to 5 TeV, and possibly in 2011 to push it to 7 TeV per beam or thereabouts.
Putting the non-LHC experiments aside, there will have been no physics at CERN since the year 2000 when LEP was dismantled. How do you feel about this, and what do you personally expect from this new era which is about to start for particle physics?
Well, LEP was a fantastic machine which operated for 12 years and did some fantastic precision physics. The LHC will be a discovery machine. Mm-hmm. It's fairly sure that we will discover something. Some people think they know what it will be. Other people are hoping for things which they've never thought of before. Mm. So I think, although we haven't had high-energy frontier physics since the year 2000, the CERN physics program, fixed target, AD, NTOF, and so on, is a very, very complete program. There's been a lot going on. But of course, everyone wants to do the discovery physics, and we hope to start back after about 10 years of LEP to doing more discovery physics. Yeah.
Wonderful. Well, many thanks, Dr. Myers, and we wish you all the best for high-energy collisions.
Thank you.
Thank you.